please take out your notes paper and please follow along. If I am going too fast, please ask the sub to pause the video. Our objective today is the student will graph inequalities. So far you guys have been working on equations. And an equation looks like this. And you got to figure out what does x have to equal so that when you add 3 to it, you get 5. So we subtracted 3 on both sides, and we got x equals 2. So that means when x is 2, 2 plus 3 is 5. There was one solution, one answer for x. In this lesson, you are going to be given an inequality. And an inequality has a symbol like this that looks like the alligator mouth. And this time when we solve this, we don't get that x equals one number. We get that x can be any number that is greater than 2. So for example, a number greater than 2 would be 5. So if I replace the x with a 5, 5 plus 3 is 8, and 8 is greater than 5. X could also be 7, because 7 is greater than 2. So if I put in a 7, 7 plus 3 is 10. So what you need to see here is before we went from having one solution, one answer, to now x could be many different numbers. Okay, so an inequality has the following symbol. So instead of the equal sign, instead of this symbol, we're now going to have these symbols in our problem. Inequalities typically always have many solutions, where equations typically have just one. A solution, another word for that is answer, makes a true statement when it replaces the variable. Okay, so let's take a look at some examples to make sure we understand that. Tell whether the given value is a solution. Write yes or no. So I want to know, could y be 4? So 4, and remember the mouse, okay, think of like a Pac-Man, wants to eat more. So this is asking you, is 4 greater than 5? Or is it equal? So this little line, the little line underneath, means it's okay to be equal also. So is 4 greater than or is it equal to 5? No. Okay, is 5 a solution? So I'm going to take out the y. And this says, is 5 greater than 5? No. But this means equal, so yes. Okay, then it wants to know, could y be 7? So this is red. Is 7 bigger? Is it greater than 5? Or is it equal to 5? Yes, it's greater than 5. Okay, this says x can be any number that is less than -3. So let's see if 6 could work. So is 6 less than -3? No, 6 is more. I'd rather have $6 than $3. So this is false. So no. 6 can't be x. So remember on a number line that the numbers on the left side of 0 are all negative and the numbers on the right side are all positive, and it gets bigger and bigger and bigger and bigger. So 6 is right here. Negative 3 is right here. 6 is bigger. Okay, then it wants to know, is negative 3 a solution? So I'm going to take out the x and put in a negative 3. And this says, is negative 3 less than negative 3? No, they're equal. It doesn't have the line underneath. If it did, it would be yes. Okay, then is negative 10 a solution? So is negative 10 less than negative 3? Yes. I'd rather owe someone $3 than owe someone 10. So this means I'm going to have more money if I only give someone 3. So on a number line, here's negative 3. The closer it is to the right, the bigger it is. So negative 3 means I'm going to have more than negative 10, which would be over here somewhere. So this is greater than this. Okay, is 8 a solution? So I'm going to take out the x, and I'm going to put an 8 there. So 8 minus 5 is 3. And is 3 less than 3? No, it's equal. Okay, now let's talk about, now that we understand what solutions are, they're numbers that when it replaces the variable, it makes it true. Now let's graph these problems. So when you graph, you're going to use an open circle, an open dot, if it has a symbol like this in the problem, a less than or greater than symbol. You're going to use a solid dot like this. You're going to color the circle in if it's equal to that number. And then you need to shade one of the sides of the graph, because the shading represents all of these numbers that are solutions. So remember, the shading represents all the numbers that the variable can be. Okay, so graph the inequalities. So we need to graph all the numbers on the number line that are greater than 3 or equal to. So I'm going to pick one of the spots on my graph, doesn't matter where, and I'm going to make it 3. Okay, now think about, should this circle be shaded? Think to yourself right now. Hopefully you're thinking yes, because x could equal 3. So I'm going to shade in the circle. So on a number line, the numbers get bigger and bigger and bigger and bigger on the right side, and it gets smaller and smaller and smaller on the left side. So I need a shade where all the numbers are that are greater than 3. So all the numbers that x could be are right here. So I'm going to shade the side of the graph where all the answers are. Like x could be 4, because 4 is greater than or equal to 3. X could be 5. X could be 6. Number lines go on and on and on. So is 5 a solution? So if you look at your graph, the answer is yes, because it's in the shaded parts. Is 3 a solution? So 3 is, because it's in the shaded circle. Negative 2. Negative 2 is going to be over here somewhere. It's not shaded, so it is not a solution. In other words, if x was negative 2, that is not true. Negative 2 is not greater than 3. Okay, let's take a look at another one. So we're going to put a circle on the graph, on the number line, put that number underneath, and then think about right now. should I color in this circle? So hopefully you're like, no, don't shade in the circle because it can't equal -8. It doesn't have the line underneath. You're only going to shade it in if it has the line underneath. So I'm going to leave that open because x can't equal -8, or y can't equal -8. If y was -8, this isn't true. -8 isn't less than -8, so the circle is not going to be shaded in. Okay, now I need a shade where all the numbers are that this says less than. So remember, y means all the numbers that are less than -8. So remember, on a number line, if we look at our number line here, the number line gets, the numbers on the right are bigger and bigger. The numbers on the left get smaller and smaller. I don't want to have to owe someone $11. I'd rather owe someone $6. So that's why this means I'm going to have more. So I need a shade where all the numbers are that are less, because the inequality sign is going away from the y, and the y represents all the numbers y can be. So I need a shade where all the numbers are that are less. Okay, so is -4 a solution? So remember, -4 is going to be over here somewhere. It's not shaded. So no, x can't be -4 because -4 is not less than -8. Doesn't work. It's not a solution. Okay, how about -8? Is -8 a solution? Hopefully you're thinking no, because it's not shaded in. Y cannot be -8. -8 is not less than -8. Let's check 6. So 6 is over here. It's a big number. It's not in the shaded part. So y cannot be 6. If you plug it in, it doesn't work. 6 is not less than -8. No, it doesn't work. Okay, let's try one more example here. So we're going to take 5, put a circle, and I want you to think right now, should I shade in the circle? So hopefully right now your brain's going, yes, shade the circle in because it has the line underneath. It means x can equal 5. Then, if you notice, this one's a little bit different. The variable's first on these two problems. This one it's not. So I need to read this like this, from right to left. This is saying x, so the number's for x, and notice the mouth is going to the x. It wants to eat the x, so it wants more. So that means x has to be bigger numbers. X has to be bigger than 5. So again, our number line gets bigger and bigger and bigger on this side, and the numbers get smaller and smaller and smaller. So it says shade where all the numbers are bigger than 5. So the numbers are bigger on the right side. So is 5 a solution? So look at 5, and it's shaded in, so yes. If I plug it back in here, 5 is less than or equal to 5. It works. It's equal to. That's why it's yes. Okay, is 2 a solution? Is 2 shaded? No. In other words, 2 is less than or equal to, 5 is not less than or equal to 2. So no, that's not true. The mouth is going to 2. That's wrong. It should go to 5. 5 is bigger. So no, it's not shaded. Is 8 a solution? So 8 would be over here in the shaded part. It's a big number. It's bigger than 5. So yes. And if I check it, 5 is less than or equal to, replace the x with the 8. Yes. Alrighty, so if the sub would now pass out your homework, which is, let's change this right now. If you go back to the top of your notes, this is lesson 38. So if you would please pass out lesson 38 so the students can start on their homework in class. If you should have any questions, please come see Miss Mizuko in room 312. Have a great day.